Welcome to our journey into the world of satellite communication. Have you ever wondered how your phone call reaches across continents or how live broadcasts from space are possible? It's all thanks to satellites orbiting high above the Earth. In this video, we'll explore what satellite communication is, how it works, and why it's so important in our daily lives. From enabling global internet access to supporting navigation and weather forecasting, satellites play a crucial role in keeping our world connected. Let's start by understanding the basics of satellite communication and its incredible impact on modern society. Satellite is any object that orbits another object in space. In the context of communication, we're talking about artificial satellites, machines launched into orbit to relay signals. These satellites act as relay stations, receiving signals from one location on Earth and transmitting them to another. Without them, many of the services we rely on, like GPS, television, and internet, wouldn't be possible. Satellites come in various shapes and sizes, each designed for specific tasks, but their main purpose in communication is to bridge distances that would otherwise be impossible to cover. Satellite communication works by sending signals from a ground station up to a satellite, which then retransmits the signal back down to another ground station. This process is known as uplink and downlink. The satellite acts as a mirror in space, bouncing the signal across vast distances. This technology allows us to communicate over oceans, mountains, and remote areas where traditional cables can't reach. The entire process happens in fractions of a second, making real-time communication possible no matter where you are on the planet. There are several types of communication satellites, each serving different purposes. Geostationary satellites remain fixed over one spot on Earth, making them ideal for television and weather monitoring. Low Earth orbit LEO satellites move quickly around the planet and are used for internet and phone services. Medium Earth orbit MEO satellites are often used for navigation systems like GPS. Each type of satellite is positioned at a specific altitude to best serve its function, ensuring reliable and efficient communication worldwide. Geostationary satellites orbit the Earth at about 35,786 kilometers above the equator. They move at the same speed as the Earth's rotation, so they appear stationary from the ground. This unique position allows them to provide continuous coverage to the same area, making them perfect for broadcasting and weather observation. Because they stay in one spot, ground antennas can be fixed in place, simplifying the setup for users and broadcasters alike. Low Earth orbit LEO satellites operate much closer to the Earth, typically between 500 and 2,000 kilometers above the surface. Because they move quickly, a network of LEO satellites is needed to provide continuous coverage. These satellites are especially useful for high-speed internet and mobile phone services, as their proximity to Earth reduces signal delay. Companies like SpaceX and OneWeb are building large constellations of LEO satellites to bring internet access to even the most remote regions. Medium Earth orbit MEO satellites are positioned between LEO and geostationary satellites, usually at altitudes of 2,000 to 35,786 kilometers. MEO satellites are commonly used for navigation systems like GPS, GLONASS, and Galileo. Their orbits allow them to cover larger areas than LEO satellites while maintaining lower latency than geostationary satellites. This balance makes them ideal for applications that require both broad coverage and accurate timing. Satellites use different frequency bands to transmit signals, such as C-band, Ku-band, and Ka-band. Each frequency band has its own advantages and is chosen based on the application. For example, C-band is less affected by rain and is often used for television broadcasts, while Ka-band offers higher data rates for internet services. The choice of frequency impacts the quality and reliability of communication, especially in challenging weather conditions. Ground stations are essential components of satellite communication systems. They use large antennas to send and receive signals to and from satellites in space. These stations are strategically located around the world to ensure continuous coverage and reliable connections. The antennas can be fixed or movable, depending on the type of satellite they communicate with. Ground stations also house sophisticated equipment to process and route the signals, making sure data reaches its intended destination. Transponders are key devices inside communication satellites. They receive incoming signals from Earth, amplify them, change their frequency, and then retransmit them back to the ground. Each satellite can have dozens of transponders, allowing it to handle multiple channels simultaneously. The efficiency and capacity of a satellite largely depend on the number and quality of its transponders, making them the heart of satellite communication system. Satellite communication touches our lives in more ways than we realize. From watching live sports events and international news to making phone calls from remote locations, satellites make it all possible. Even when you use GPS to navigate or check the weather forecast, you're relying on satellite technology. These invisible helpers in the sky ensure that we stay connected, informed, and safe no matter where we are. One of the most exciting developments in satellite communication is the push for global internet access. Companies are launching thousands of small satellites to create a network that can provide high-speed internet to every corner of the globe. This technology is especially important for rural and underserved areas, where traditional infrastructure is lacking. With satellite internet, the digital divide is slowly closing, bringing new opportunities for education, business, and healthcare. Satellite phones are a lifeline in remote and disaster-stricken areas. Unlike regular cell phones, they connect directly to satellites, allowing users to make calls from anywhere on Earth. This makes them invaluable for emergency responders, explorers, and people living in isolated regions. Satellite phones ensure that communication is possible even when traditional networks are down or unavailable. Satellite communication revolutionized television broadcasting. With satellites, TV signals can be sent to millions of homes across continents in real time. This technology allows for live coverage of global events, international news, and entertainment, making the world feel smaller and more connected. Satellite TV remains a popular choice, especially in areas where cable infrastructure is limited. Navigation systems like GPS rely on a network of satellites to provide accurate location and timing information. Whether you're driving, hiking, or shipping goods across the ocean, GPS satellites guide you every step of the way. These systems are essential for transportation, logistics, and even emergency services, ensuring that people and goods reach their destinations safely and efficiently. Their satellites monitor the Earth's atmosphere, oceans, and land to provide accurate forecasts and track severe weather events. These satellites collect data on temperature, humidity, cloud cover, and more, helping meteorologists predict storms and warn communities in advance. Satellite weather data is vital for agriculture, aviation, and disaster preparedness, saving lives and property every year. In times of natural disasters, satellite communication becomes a critical tool for emergency response. When traditional networks are damaged or overloaded, satellites provide reliable communication for rescue teams and aid organizations. They enable coordination, resource allocation, and real-time updates, ensuring that help reaches those in need as quickly as possible. Satellite communication is vital for military operations and national security. Armed forces use secure satellite links for command, control, and intelligence gathering. Satellites provide real-time surveillance, navigation, and communication, ensuring that military units can operate effectively anywhere in the world. The reliability and security of satellite communication make it a cornerstone of modern defense systems. Satellites are essential tools for scientific research and space exploration. They collect data on Earth's environment, climate, and even other planets. Communication satellites relay information from space missions, enabling scientists to study distant worlds and expand our understanding of the universe. Without satellite communication, many groundbreaking discoveries would not be possible. Live broadcasts of sports, concerts, and global events rely on satellite communication. Satellites transmit high-quality video and audio signals to viewers around the world, making it possible to share experiences in real time. This technology brings people together, allowing audiences everywhere to witness history as it happens. Satellite communication plays a key role in remote education, especially in areas without reliable internet or infrastructure. Educational content can be broadcast via satellite to schools and homes, ensuring that students everywhere have access to learning resources. This technology helps bridge educational gaps and supports lifelong learning. Telemedicine uses satellite communication to connect doctors and patients in remote areas. Medical consultations, diagnostics, and even surgeries can be performed with the help of real-time video links. This technology improves healthcare access and outcomes, especially in regions where medical facilities are scarce. Satellites provide vital communication links for ships at sea and aircraft in flight. These connections enable navigation, weather updates, and emergency communication, ensuring the safety of passengers and crew. Satellite communication also supports entertainment and internet access on long journeys, making travel more comfortable and connected. Internet of Things, IoT, connects devices and sensors around the world, and satellites play a crucial role in this network. From monitoring pipelines and crops to tracking wildlife and vehicles, satellite communication enables real-time data collection and analysis. This connectivity drives innovation in industries like agriculture, logistics, and environmental monitoring. Banks and financial institutions use satellite communication to ensure secure and reliable transactions, especially in remote locations. ATMs, branch offices, and mobile banking services depend on satellite links to stay connected to central systems. This technology helps maintain financial services even during network outages or disasters. Businesses of all sizes rely on satellite communication for connectivity, especially in areas with limited infrastructure. From oil rigs to construction sites, satellite links provide internet, phone, and data services. This ensures that operations run smoothly and teams stay connected, no matter where they are located. Despite its many benefits, satellite communication faces several challenges. Signal delay, known as latency, can affect real-time applications. Weather conditions like heavy rain can interfere with signals, especially at higher frequencies. Additionally, the cost of launching and maintaining satellites is significant. Engineers are constantly working to overcome these obstacles and improve the reliability and efficiency of satellite communication. Recent advancements in satellite technology are making communication faster, more reliable, and more affordable. Innovations like reusable rockets, miniaturized satellites, and advanced signal processing are revolutionizing the industry. These developments are expanding access to satellite communication and opening up new possibilities for global connectivity. Satellite constellations are groups of satellites working together to provide continuous coverage. Companies like SpaceX and OneWeb are deploying large constellations of LEO satellites to deliver high-speed internet worldwide. These networks ensure that users always have a satellite overhead, reducing latency and improving service quality. Launching a satellite is a complex process that involves careful planning and precision engineering. Rockets carry satellites into space where they are deployed into their designated orbits. Once in position, satellites undergo testing before beginning their communication duties. The entire process requires coordination between engineers, scientists, and mission controllers to ensure success. Satellites must be carefully maintained to ensure they continue operating effectively. Ground teams monitor their position, health, and performance, making adjustments as needed. Some satellites are equipped with thrusters to correct their orbit, while others rely on software updates and remote troubleshooting. Regular maintenance extends the lifespan of satellites and maximizes their value. When a satellite reaches the end of its operational life, it must be safely decommissioned. Some satellites are moved to a graveyard orbit while others are guided to burn up in the Earth's atmosphere. Proper disposal is important to prevent space debris, which can pose risks to other satellites and space missions. Space debris, or space junk, consists of defunct satellites and fragments from collisions. This debris poses a threat to active satellites and space missions. Managing space debris is a growing challenge, and international cooperation is needed to develop solutions that keep space safe for future generations. Satellite communication is a truly global endeavor, requiring cooperation between countries and organizations. International agreements govern the use of orbital slots and frequencies, ensuring fair access and minimizing interference. Collaboration also helps address challenges like space debris and cybersecurity, making space a safer and more productive environment for all. Radio spectrum used by satellites is a limited resource, managed by international bodies like the International Telecommunication Union, ITU. Regulations ensure that different users and services can coexist without interference. Effective spectrum management is essential for the smooth operation of satellite communication systems worldwide. As satellite communication becomes more widespread, cybersecurity is increasingly important. Protecting satellite links from hacking, jamming, and unauthorized access is crucial for national security, business, and personal privacy. Engineers use encryption and advanced security protocols to safeguard data and ensure the integrity of satellite networks. Launch and operation of satellites have environmental impacts, from rocket emissions to space debris. Companies and agencies are working to minimize these effects by developing greener launch technologies and responsible disposal practices. Sustainable satellite operations are essential for protecting both our planet and the space environment. Future of satellite communication is bright with new technologies on the horizon. Advances in laser communication, quantum encryption, and artificial intelligence promise to make satellite networks faster, more secure, and more efficient. As demand for connectivity grows, satellites will continue to play a central role in shaping our digital world. Satellites are set to play a key role in the rollout of 5G networks, especially in rural and hard-to-reach areas. By providing backhaul connections and extending coverage, satellites help ensure that everyone can benefit from the speed and capabilities of 5G technology. This integration will further enhance global connectivity and digital inclusion. Smart cities use satellite communication to manage infrastructure, monitor traffic, and provide public services. Satellites enable real-time data collection and analysis, supporting efficient city management and improved quality of life for residents. As urban areas grow, satellite technology will become even more important in building sustainable and connected communities. Farmers use satellite communication to monitor crops, manage irrigation, and track equipment. Real-time data from satellites helps optimize yields, reduce waste, and improve sustainability. This technology is transforming agriculture, making it more efficient and environmentally friendly. Satellites provide critical data for monitoring the environment, tracking deforestation, pollution, and climate change. This information supports conservation efforts and helps policymakers make informed decisions. Satellite communication ensures that environmental data is shared quickly and accurately around the world. Space missions from lunar landings to Mars exploration rely on satellite communication to send data back to Earth. Satellites relay images, scientific measurements, and status updates, enabling mission control to guide spacecraft and analyze discoveries. This technology is essential for exploring the solar system and beyond. From satellite TV to GPS navigation and satellite internet, individuals benefit from satellite communication every day. These services make life more convenient, safe, and connected, whether you're at home, on the road, or traveling the world. Satellite technology continues to evolve, bringing new possibilities to personal communication. Satellite communication has transformed the way we live, work, and connect with each other. From enabling global communication to supporting scientific discovery and disaster response, satellites are an indispensable part of modern life. As technology advances, satellites will continue to break barriers and bring the world closer together. Thank you for joining us on this exploration of satellite communication and its incredible impact on our world.